Today's lesson is on adding and subtracting rational expressions. So first we're going to start with adding and subtracting rational expressions with like denominators. Remember, when we add or subtract fractions, the denominators must be the same in order to add the fractions. If the denominators are the same, then simply add or subtract the numerators and then reduce. So, for example, if you have a over c plus b over c, notice that the denominators are both c. The denominator will stay c, and the numerators you just add. The second one is the same thing but subtract. In that case, you would just subtract the numerators. Let's add these fractions. So 5/6 plus 11/6, they both have the same denominator 6, and it stays 6. 5 plus 11 adds up to be 16. Now, if you can reduce your fraction, you always must reduce your fraction. So 16/6 does reduce by a factor of 2. So if I divide the numerator by 2 and the denominator by 2, I'm getting 8/3. Let's try this with rational expressions. Make sure that you reduce your answers at the end. Our first problem is 25 over 3x minus 4 over 3x. Notice that both of the denominators are the same, so that they will stay the same. So and all I have to do with the numerator is add or subtract it. In this case, 25 minus 4 is 21. Now, if it didn't reduce, I would be done. But notice that the 21 and the 3 both have a common factor. I could rewrite it as 7 times 3 over 3x. And the 3's divide out. And my final answer is 7 over x. On the next problem, we have more terms in the top and more terms in the bottom, but notice the entire denominator, 5x minus 2, is the same on both. That is necessary in order to add or subtract the problem. So once it's the same, it just stays the same. In the numerator, I have 3x plus 1, and I'm adding that to 4x minus 6. So that symbol in between there is add. The denominator is going to stay the same, and all I'm going to do is combine like terms in the numerator. I have 3x plus 4x is 7x. 1 plus a negative 6 is negative 5. And if that reduced, I would need to reduce it, but it doesn't factor, and there's no common factors that divide out nicely, so that's my final answer. On the next problem, notice that we have 2x plus 3 on both denominators, so that denominator is going to stay the same, 2x plus 3. In the numerators, we have more than one term on the second numerator, so we need to be a little bit careful here. I have x squared on my first numerator, and then I have x plus 6 on the second denominator, but in this case we have a subtract sign. Because I'm subtracting, I have to put parentheses around the second fraction's numerator so that I subtract not just the first term, but all of the terms. So that's like if I had a negative 1 here and it distributes through. The denominator again stays the same, so when I rewrite it, the first thing I like to do is to rewrite the denominator. And then in the numerator I have the x squared, his sign doesn't change, but when I distribute the negative through the entire second fraction's numerator, I get minus x minus 6. If you're getting a plus 6 there, you're not putting parentheses and you're not distributing your negative 1, so please be careful there. Now, the numerator looks like it might be able to factor, so I want to make sure that this doesn't reduce, so I'm going to factor this out to, see, that's x minus 3 and x plus 2. The denominator again still stays the same. Now in this case, I factored it out and it didn't reduce at all, which means this is a correct answer, completely reduced, but so is the one right before it. You always need to factor and check to see if anything cancels. But in this case, if you forgot to factor, well, lucky you, I wouldn't probably catch you because either one of these is the same because nothing divided out to 1. But if something did divide out to 1 and you forgot to factor, well then you'd mess up your problem and you wouldn't get it 100% correct. On our next problem, we have y plus 1 in both denominators. That's good news. So I just keep that in the denominator. In the numerator, it is a subtract problem, but because there's only one term in each numerator, the first fraction only has 8y squared, and the second fraction only has 8y, I don't really need to put parentheses around it because there's only one term, and I don't need to distribute to more than one term. So when do you need to put parentheses around it? Well, when you have the subtract and when you have more than one term in the second fraction. Okay, let's finish this problem. So we got 8y squared minus 8y in the numerator. Now, that doesn't combine like terms, but I could factor it out. So when I factor it, I get 8y as a GCF, and then y minus 1. And you should look at the numerator and the denominator and see if there's anything that divides out to simplify it. Looks like the y minus 1 divides out nicely, and so my final answer is just 8y in the numerator. You don't need to put over 1. That's a little unnecessary. Now in this next section, we're adding opposite denominators. Notice that the denominators are really close, but they're not quite the same. So we are going to learn how to make them the same when they're very close and they're only off by a negative. So the first thing I want to do is rearrange all of my denominators so that they're in the same order with x's in the front and numbers in the back. So the first one is correct with the x in the front and the number in the back. But on the second fraction, I would prefer the negative x to be in the front and the plus 2 to be in the back. Then I'm going to factor out, if there's any negatives in the front, I need to factor that out. So I'm going to factor negative 1 out. Now you can see that the denominator of the first fraction and this non-negative part is the same. The only problem is that we have this negative in front, this negative 1. Well, we're going to do something a little bit tricky here. And we are going to take this negative right here and this negative right here and multiply them together, or add a line, change the sign. So a negative times a negative is really going to be a positive. So I'm going to change that into a plus sign in between, and it gets rid of the negative in that denominator. So I really have x minus 2 on the first fraction's denominator and x minus 2 on the second fraction's denominator, because the negative times a negative multiplied to be a positive, so you don't have to write the negatives either negative. Now the numerators are still staying the same, and now I can continue and finish my problem. Now that the denominators are the same, I get x minus 2 in the denominator, and in the numerator 5 plus 6 is simply 11. And that is my final answer. Let's do this again. So on the next problem, y is in the front and 3 is in the back. The variables in the front, the numbers in the back, that's great. But on the second fraction, it's out of order. So I'm going to first put it in order, negative y plus 3. So then I'm going to factor out a negative 1 as a GCF. And I can see that the two fractions are looking awfully similar now. We have y minus 3 here and y minus 3 here. We just need to get rid of that negative 1 in front. Well, last time the negative times a negative turned out to be positive, and that was pretty easy. But this time we have a positive times a negative. Well, a positive times a negative is a negative. So what I'm going to do is I'm just going to multiply these two numbers together and make the sign in between it minus. So we have x over y minus 3 minus 5x over y minus 3. You don't have to put the negative 1 in the denominator because you multiplied these two numbers together and got negative. Now that the denominators are the same, it stays the same. X minus 5x gets you negative 4x. There's nothing to factor and nothing else divides out to 1, so that's my final answer. Notice that the two denominators, x minus 4 and 4 minus x, again, are similar but not quite the same. To make them exactly the same so that we can add them, we need to rearrange the order of the second denominator so that the variable's in the front and the number's in the back. The next thing you want to do is factor out a negative 1 out of the denominator. Notice that I really didn't do anything with the numerators, so they're just going to come along. At this point, I want to get rid of the negative in that denominator. So I'm going to take the sign in between the two fractions times the sign in that denominator that I would like to get rid of and multiply them. A positive times a negative turns out to be a negative. And now my denominators are both x minus 4. At this point, I can combine like terms and subtract my numerators. The denominator will stay the same. And because this is a subtract problem with a polynomial in the back, I need to remember to put parentheses around the second numerator so that I'm not just subtracting the first term in that numerator, but I need to be subtracting all terms in that numerator, which gets me 3x squared minus 7 minus x squared plus 2x minus 12. Next, I will combine like terms. 3x squared minus 1x squared is 2x squared. And the x's, I only have one term of x's, that's 2x. And then negative 7 minus 12 more is negative 19. Now that numerator does not factor, so this is our final answer.